Hello everyone, my name is Mohamed Abwa. This is lecture 1 on Android, how to develop mobile apps for the Android platform. A little info about the course. It's going to consist of 4 lectures that are posted online, and then the in-class time will actually be used to go over examples and problems. That's where all the programming is going to be. There will be no code posted in these online recorded lectures. The goal is to learn enough to continue on your own. In 4 lectures, I can't teach you all of Android, of course. You're going to learn here just the basics of how to build a basic app and where you can find information and what kind of stuff you can and can't do, just enough for you to start working on your own and learning the rest. So that'll include Android basics, how to find and use online resources, how to use the actual IDE Android development tools. We will be using Eclipse, not Android Studio. That is still in alpha, and I'm more used to Eclipse. And we may get into basics of test-driven development, though it's unlikely. We'll see how the time goes. Now, one thing to keep in mind is I will assume that you know how to program and you know object-oriented programming. That I will not be teaching you how to program or how to use object-oriented programming. I will just be teaching you how to program in Android. The language we'll be using is Java with a little tiny bit of XML. So, a bit of Android info. It was actually acquired by Google in 2005. It wasn't actually built by Google since the beginning. They were invested with that company in the beginning, but then Google bought them out in 2005. It's completely open source, and that actually helps a lot. There was often many times where I would need to look at Google's source code to see how something was implemented or to see if there was a bug in their code or mine. And because it's open source, it's really easy to mod and port. It's also because it's based on Linux kernel. We'll get into that a little bit later. There's websites like CyanogenMod that will show you many mods for all kinds of devices. It's really easy to ship to the market compared to iOS. There is no revision. You just submit to the store, and within an hour or so, it'll show up. It has the largest market share actually right now. It sits at about 81% of all smartphones shipped in the US or North America, I'm not entirely sure, were from Google Android phones, which means that 19% of the market is all that's left for Apple, Microsoft, BlackBerry, and all the rest. And that citation will provide the info. So let's get into a little bit of Android development. So the basics. There are 4 main components for an Android app. Not all of them must be there, but the most common are these. So activities, services, content providers, and broadcast receivers. Activities are single screens that the user will interact with. So when you are browsing your Gmail app and you're looking at a list of emails, that's an activity. When you click on an email and a new screen pops up with more buttons and more information, that's usually another activity. Even the Android system is also based on activities. When you're looking at your home screen, that too is an activity. So activities are the places where user interaction occur, where you see things, where you can click buttons, where you see things animating in, out, video, all of that happens in activities. Services are more or less run in the background. So when you open up the activity of your music player app and you hit play, and then you leave the activity or you leave the app, since that's the only activity left, you leave the app closes down, but the music is still playing. That happens in a service. Now, one thing to keep in mind, a service does not actually run in the background. It runs on the UI thread, so you do not want to do any blocking logic on the UI thread. But yeah, that's what is used to keep something running in the back while some other app is in the foreground, or yours, it could be any. But if your app is not to be in focus and you want to do some logic, you use a service usually. Content providers, by their name, provide content. So for example, all of your contacts on the app, on your phone, are saved in a contacts content provider. And there's similar ones for like the email content provider, and there's a whole bunch more. But basically, these guys provide a little more functionality than a regular database because it actually synchronizes with the Android system. So if there's no internet, it won't let the content providers update. It'll handle failures. If you're in the middle of an update and things go down, it'll handle it for you. It'll do bulk inserts and that kind of stuff. So it's a little wrapper with the uniform resource indicators on them, URIs, to help specify which content provider is which and how you get information and what information are you interested in. So that's what a content provider is. Broadcast receivers, a little info before I actually get into them. So the way Android works is the way messages are sent between apps or by the system are using things called intents. So when your battery is low, how does a certain app know that the battery is low? It's because of intent. When you go on the main screen and you click on an app, how does the app know that it has to be launched and that kind of stuff? It also works via an intent. So what happens is a lot of things Android will broadcast via an intent when you have low battery, whenever you are now connected to the internet, you're no longer connected to the internet, when a headphone has been plugged in, all of that kind of stuff, the system broadcasts but via an intent. And how do you listen on that broadcast, or how do you say I'm interested in this kind of information? You do it by a broadcast receiver or an intent filter. That's also how widgets work. If you have a widget on your main screen, you click something and the app pops up or it does something else, that's usually done also by a widget. All of these components are defined in code, but when you download an app from the App Store, there's information there provided about what kind of what kind of features it has, what version is, the name of the app, the icon, what permissions does it use, what permissions does it declare. All of that kind of stuff is metadata about the code, about the app. And the Google Play Store cannot read your code and figure all of that stuff out. It's all specified in the Android manifest file. So, right. Out of all of those four components, the only ones we'll be going through are activities. Services, content providers, and broadcast receivers are used, but not as often as activities. And arguably, activities are the most important component. So an activity is a single focused screen that is usually used to interact with the user. This is what you see, this is what you work with. I highly recommend you read the Android developer resource because it will introduce you to a lot of things of how Android works, not just activities. Because an activity is such an important part of every app, it actually explains a lot more than just how an activity class works. Activities sometimes use fragments within them if you want different kinds of content within them. It's basically a smaller, it has a similar functionality to an activity, it has content within it, you can just swap it in and out. Basically, activities or fragments are arguably the most essential part of an app because that's what the user sees, that's what the user interacts with, that's what all the buttons, all the text, all the images, where video happens, all of that happens in activities and fragments. So that's where all of the UI happens and how it's defined. So when we're dealing with activities, an activity has to be, the class has to be created and defined. So when you create an activity, you have to say what kind of stuff goes in it. So do you want text? Do you want images? Do you want a list of items? Do you want the activity to start fetching stuff from the internet? All of that kind of stuff gets defined in the code. That's where the UI comes in. And then some activities are a little special. That's where the manifest comes in. So for example, if you are in your browser and you click on a certain email, like a mail to link, the Gmail Compose activity will pop up. If you look through your recent apps, chances are the Gmail app doesn't show up, which means you launched an activity within the Gmail app or some other app in some cases without actually launching that app. So how does the system know that this certain activity in that app can handle emails or sharing, like Facebook and Twitter when you click the share button? That kind of stuff is defined in the manifest. Another thing is when you want to specify which activity it is that launches with the app. So when I'm looking at the main home screen and I click on a certain app and the app launches, you're looking at a certain activity. You need to tell the Android system which activity it is that actually has to be launched in the beginning and which activity shows itself on the main screen. Some apps have more than one icon on the main screen. Pretty rare, but happens. So that's where you create an activity and define it. You have to define the code, define how it looks, and then define it in the manifest with any other metadata that you need, such as it's a launcher activity, it's the one that comes up in the beginning, or the fact that it can handle a share intent and that kind of stuff so that it can share, or it can do calls, text messages, or any kind of stuff like that. You define it all in the manifest so the Android system knows how it works. So now let's assume we've created our activity and defined how it works and put it in the manifest. I need to actually bring it up. I need to actually start it. I need to actually have it come into focus. So that can be done in more than one way. One of the most common ways is by actually just clicking an app on the main screen. If you click an app on the main screen, that will launch the app and the very first activity it defines. So that's one way of starting an activity, getting an activity to actually be created and come into focus. Another way is from within an app. If you click a certain button, so as I said, if you're looking at the Gmail app and you're looking at a list of emails and you click on a certain email, a new activity will pop up and show you the details of that email. There you clicked something and the app launched another activity within itself. Activities stack up. So when you hit back, you leave the activity that you have in focus and you go back to the one before it. When you finish an activity, how do you shut down activities? By calling finish on it. Sometimes it's finished in the app. So for example, if you're composing an email and you hit send, chances are that activity is going to go away and it's going to go back to where you were before. That's one way of doing it manually. The other is just hitting back, where the Android system will take care of it for you. By default, hitting back when you're looking at any activity will just leave that activity, finish it off, and get it destroyed, and it'll go away. Now you can override that functionality if you want to do your own thing, such as many apps will give you a pop-up dialog saying, are you sure you want to exit? But by default, it just finishes an activity and leaves. So when I'm dealing with an activity, I need to do things in its life cycle. So how does an app detect that the activity is being destroyed and ask you, are you sure you want to exit? That happens as a certain method in the activity. How do you know when an activity is being created so you can prepare all of the UI for it, or maybe fetch some data if you're dealing with a Twitter app or something like that? All of those happen in the activity's lifecycle. So let's look at that. When an activity gets launched, the first thing that happens is it gets created. Then it gets started, resumed, and it just waits. This is where it is while it's in focus. Now, later on, you could, let's say, leave the activity. You hit back, or the system runs out of memory and it wants to close that app. Then what will happen is that activity will get paused, stopped, destroyed. As you can tell, they're kind of opposites. You get created, you get destroyed. You get started, you get stopped. You get resumed and paused. Now, what's important here is to remember that on create and on destroy only happen once in the lifetime of an activity. However, on start, on resume, on pause, on stop happen often. The reason that's important is you only want to create your views, as they're called, or things that you show on screen only once. So if an activity comes into focus and leaves and then comes back again, you don't want to recreate everything and refetch the data. For example, you opened up the Twitter app, it showed you everything, and then you hit the home button. You put the app in the background. That activity didn't get destroyed, unless you're running out of memory, but that's a separate issue. But that activity won't get destroyed. What will happen, it'll get paused and stopped, and it'll wait. And then if you long press your home button and you swipe it away to close the app, that's when it gets destroyed and the whole app goes away. But let's say you didn't destroy it. You just put it in the background, you long pressed, you went into the multitasking, long press on some phones, or just press the multitasking button, and then you'll see the app again, click it again, and if you bring that activity back into focus, you come into on start. And then on resume, and you go back into focus, and it waits again. So these are the essential lifecycle methods. There's many more. There's on restart, on saved instance state, on post create, many more that you could use. But the most important ones are on create, on start, on resume, on pause, on stop, on destroy. We will be using these a lot. So what do you see? What you actually see in an Android app is a thing called a view. An activity itself is just, you can consider it the controller. It controls what happens with views. It controls its life cycle. It controls what happens when you're looking at that activity or in that state of the app. What you actually see are views. So there's many kinds of views. Some of the views that might make sense are text views, image views, buttons, edit text. Edit text are things you type in. So it's like a text view, but where you're typing in, like a search bar. There's many views that are actually visible themselves. So text view, image view, button, and all of that kind of stuff. There's other views that manage other views in a way. So when you are looking at a list, an item in the Gmail apps list, what you see there is usually an image on the left, and then there's the title at the top, or maybe I think it will be the sender at the top, and then the description at the bottom, and maybe a couple of icons at the right, or depends on how you set up your app. But those are a bunch of views all encompassed in one cell of the list. That cell could be a relative layout or linear layout or a frame layout, but basically it's not visible itself. All the cell does is manages its children, manages the views under it, puts them in positions relative to each other. So that might be the case with the Gmail app, relative in the sense that the image goes at the very left of the parent, and then to the right of it you have your headline, and under that you have your text, and then to the right of that you have another icon. Any relative placement like I just described, above, below, to the right of, aligned to the right of this, above that, all of that kind of stuff happens in a relative layout. Linear layout will place items linearly. So, I mean, you can kind of imagine this list as a linear layout. It just places items right after each other. So that might be useful, for example, in a menu. In Google's, for example, in Google's email, if you're looking at the browser or the app, there's lots of items that are just placed linearly beside each other. There's no relative placement above, below. It's just simply a straight line of items beside each other. For example, in the Microsoft Office PowerPoint app, all of the icons you see at the top, the menu, I think it's like font size, shape, superscript, subscript, all of those are just beside each other. You use a linear layout for that. You can do it with a relative, but it makes more sense with a linear. A frame layout just sits as a frame. So if you want to have only one view in the middle, but you want to have it surrounded by a lot of space, or maybe just give it a background color, you just want a frame for it, you use a frame layout. Or if you want to place multiple views on top of each other and have transparencies, then you would use a frame layout. A frame layout does not do any work for collisions, for any placements. It just sits there and lets whatever happen. There's many more, of course. There's scroll view, list view, grid layout. There's many more, but these are just a basic idea. Now, one thing that's important is to know that the way an activity works is you only have one view at the very top. It's structured as a hierarchy. Let's see if I can show you what I mean by that. So here's a UI overview. Yeah. So you have one view at the very top of your activity, and then you have children views, and then even more, and it goes on from there. It's a tree structure. Now, you could have just a view at the top. Every view group is also a view. You could have one at the top and more children, or you could just have one. In our case, the very first app we're going to build is Hello World, and that will just have a text view at the very top. And your view hierarchy for an activity can be defined programmatically or interactively using the IDE. Almost no one does it programmatically because it's actually a real big pain to build it that way. Most people do it interactively, which is using the Eclipse IDE or Android Studio to build it with XML. You don't define it in code, you define it in XML, and you can actually see it as you go in the IDE. The IDE gives you a preview. So the Android manifest, it's an XML document in which all the important information is declared. It's read by the Android system and the Play Store. So as I said, this is where you define metadata about your app, permissions you declare, permissions you use, all of that kind of stuff. The manifest includes the application permissions declared and used. Used permissions are things like it can detect your battery level, it can use the internet, it can change your contacts, it can make calls, it can use your camera, that kind of stuff that you see in the Play Store. Declared, some apps it's pretty rare, but some apps will actually define their own permissions that other apps can use. So a simple example for me might be the camera app. Even though it's part of the Android system, but it can actually be declared its own app, and that might have its own permission. When you use the camera, you are using a permission declared by the camera app. Another thing that's included in the Android manifest is the SDK version. So this is the Android version. So this is what refers to gingerbread, ice cream sandwich, Kit Kat, Jelly Bean, Honeycomb, Eclair. All of those kinds of versions of Android are matched with an SDK version or an API number. It's the same thing, API level as they call it. When you're creating an app, you have to specify a target. As in, my app targets this version of Android. I am building it for Android KitKat 4.4 or Jelly Bean or any of those kind of things. But you should always also specify a minimum. Even though I'm targeting KitKat, I want to also support down to gingerbread, for example, or Jelly Bean or ice cream sandwich. Those have specific numbers. We'll go through them in a little bit. So that's the kind of stuff you also define in the manifest. Your application object or your application properties. So let's say sometimes you want to have some information that lives with the entire application, not a certain activity or a certain service, but you just want it to be alive the length of the application. That's where you can define an application object and work with it there. That's where the package name goes. For those of you who have worked with Java, you almost always need to specify a package name. So in Apache's case, it would be org.apache. In Google, it might be com.google.maps or whatever. The convention is reverse domain name. It goes from, so let's say we're dealing with Google Maps. Google Maps is usually accessed by maps.google.com. The package name for that would be com.google.maps. It's the reverse domain. That's because of a convention used in the JVM when it was initially being developed to prevent conflict. So you have many programs running at the same time, and what happens if two of them declare the same class? The way you get around that is make sure they have different packages. And to make sure the package names were unique, you use your reverse domain name. Now, keep in mind the domain doesn't actually have to exist. It's just a convention, com.something.something or ca.something.something, and so on and so forth. You also declare all of your activities, services, content providers, and broadcast receivers there. You don't have to declare all of them, all the broadcast receivers there. You can do some in code. But essential components of your app are actually declared in the Android manifest, and along with intent filters. As I said, filters you want to listen to, like sharing, like calls, texts, or the launcher intent. So let's get started in development. Some technical information about Android is that it's based on the Linux kernel. You don't have root access, but you don't really need to. That's what Android rooting is for. Native apps are written in Java. You can write some stuff native to the Linux kernel in C and C++, but most apps just work with Java. It's completely object-oriented, which is because of its Java. It runs on a Dalvik virtual machine. It's really similar to the JVM, but it's actually not the same. It was developed by an independent developer, and Google then started working with it. Now, recently, a few months ago, Android introduced ART, Android Runtime, I think is what it's called. It's a preview available only for KitKat right now, where with a little bit of changes when compared to Dalvik. So, for example, it does ahead of time compilation as opposed to just-in-time compilation, which may speed things up. And there's other stuff. Now, by default, it's still Dalvik, even on KitKat, but you can enable it, and they are working on that. And I believe that will be the norm later on. But so far, it's on Dalvik virtual machine. There's only one UI thread for Android. Why is this important? Because a thread is a single line of execution for those who don't know. And what happens is if you do something on that in your code that blocks, so let's say it's a network call, or maybe some database access that could take a lot of time, then what happens is if you do that on the UI thread will not be able to handle user interface stuff. And one thread can only be executing one thing at one time. So if it's stuck doing a network call, so downloading things from the internet, it can't refresh the screen. It can't pick up the user's touch. It can't draw things. It can't handle anything. It can't create a new activity. It can't destroy it. All of that happens on the UI thread. So in most cases, you want to do database access and network code and anything that could block. You want to do it on a separate thread so that the UI stays smooth and the phone does not freeze. Now, when you compile an app, so you've written your app, you're happy with how it works, and you want to just put it on a phone, or even if when you're developing, when you have already hit run, you just see the app on the phone. What happens is the app gets compiled into an APK package. Now, an APK package, it's kind of similar to a zip in the sense that there's nothing really fancy there, just compression and packaging. You can decompile an APK file and get out of it the Android manifest, all the resources and the code. So it's just a package like that. It's similar to a .app on Macs, where you download the program as just one big single file as .app. You run that, and that contains all the information inside. Updates. Recently, I think a couple of years ago, Android started doing updates to apps via diff files. So let's say you're downloading an update to some car racing app that's 1 gig big. If they've changed one little line of code, why should you download that entire 1 gig again? What happens is Android just detects the difference and sends a diff file, and your Android phone will re-implement those differences to get it up to spec, and it'll also verify that the patch was applied properly. Now, about limited RAM. This is in comparison to iOS. Android has supported multitasking for a long time. iOS, as of the making of this lecture, does not support multitasking. In iOS 7, they introduced a feature saying background updates, I think, where apps can come and do periodic updates, or periodic runs. But even then, an app can't continue running in the background. It can't run more than one app at the same time. Android has supported this for a while, maybe because of the Linux kernel, it just comes with it. But the downside of it is iOS was able to focus all of the system's resources on that single app that's running as well as the operating system, which means you get a lot more RAM in iOS than you do in Android. Android actually has to maintain multiple applications running at the same time, and it cannot promise all of the system resources to one app, or else other apps would starve. So what happens there is you get a lot less RAM on Android than iOS. iOS, I believe, gives you about 256 megabytes of RAM on iOS 7, or while Android only gives you up to 64. Even that's not guaranteed. Sometimes you get less on different Android phones. So you see a lot of out-of-memory issues on Android, whereas not as much on iOS. So let's do Hello World. I'm going to walk you through some technicalities of how we're actually going to start coding. The code, as I said, will be uploaded later on, or just come attend my lecture. So the first thing you want to do is actually create an Android project. In Eclipse, you right-click your project navigator, you say New, and then new Android application project. It's going to ask you a few questions. So first, it'll ask you for the project name and the application name, I think. One of them is what you see in Eclipse. One of them is what you see in on the Android phone when you're looking at the menu. And then it'll ask you for the project's domain, project's package name, the reverse domain. For us, it'll be ca.uftdev.helloworld. It could be anything else you want it to be. And then it'll ask you, and then hit next. It'll ask you to, actually it might specify the API level there. But yeah, you want to specify the API level depending on how much of Android you want to support. If you want to get most Android devices, so 98.7%, you want to go with API level 10, which is Gingerbread. But the problem with that is Gingerbread is actually quite annoying to support. There was a lot of current Android features, so similar to for example, the menu at the top, the action bar as it's called now, was only introduced in API 14 and above. Now there are ways of getting it also in Gingerbread, but it's, as I said, in general, it's just more difficult to support API level 10. It'll cost you at least a third to a half of extra development time. Most people nowadays have started opting for API level 14 and above, which is ice cream sandwich and above, ice cream sandwich, jelly bean, and Kit Kat. 11 to 13 are not really used by anyone. They were tablet only, that's Honeycomb, and it only maps to 0.1% of devices right now, so it's negligible. You will never see anyone develop almost never see someone develop an Android app for phones and include APIs 11 to 13 as the minimum. It'll be 10 or 14. Target API should be generally the most recent as you're developing. So for example, right now it would be Android KitKat 4.4 API level 19. Oh, and then you don't want to create you don't want Eclipse to automatically create an activity for you, and you don't want to create a custom icon. You don't want to create a custom icon because it just saves time as a Hello World project. You don't need that. But the reason I don't want to automatically create the activity is because I actually want to show you what happens in the beginning. So I hate magic. I hate it when you just click a couple of buttons and it just works. How did it know that this is activity that this is the activity I want to start up at launch? Well, I'm going to actually show you how that works. You don't need to do this every time. I'm just doing it for the very first time to walk you guys through the steps of creating an activity, defining what it looks like, and declaring it in the manifest, and making sure in the manifest it's declared as the one that starts up in the beginning. So the first thing we have to do is create our first activity. As I said, the first thing you see is an activity. So use in Eclipse or Android Studio, create a new Java class. It extends android.app.activity. And that gives you a basic activity. Now, if you run your app like that, you won't see anything. It might not even run. Two reasons. One is I haven't done anything to my activity. Two is I haven't even actually defined the activity to be the one that happens at launch. So what I want to do is declare it in the Android manifest so the system recognizes it as an activity, and then I want to specify that it is a launcher activity. You do that by doing two things. We'll see this in the code, as I said later on. One is you want to say I am interested in the intent that gets broadcast to my package with the name main. So you want to listen on the main intent, which is what the Android system sends out when you click on an app from the menu. The other thing you want to do is specify that this activity is of the launcher category. Activities of launcher category are the ones that are visible on your main screen. if you may have noticed that there are some apps you can download from the Play Store that will not show up on your main screen and you cannot launch. For example, I think Evernote has a widget like that where you can download it from the Play Store, but it won't actually show up as an app. That's because they didn't declare any of their activities to be of the launcher category. We'll see those later on. So now that I've defined my activity, made sure it starts up at launch, given it a name, and created the object, everything's good, except I actually need to show the text now. So in what stage of the activity do I want to actually create my views and display them? I don't want to do it in onStart or onResume because that will happen every single time the app comes into focus or the activity comes into focus. I only need it to happen once it's created, and if it leaves focus and comes back in, the text view will still remain there because it was never destroyed. So you want to override onCreate. You want to keep the default functionality, which is super.onCreate, and then you want to create a text view and then attach it to your activity. So you create a text view. You need an activity to create a text view. We'll see that in the code. You create your text view, you set the text on it to be hello world, and now I've created my text view and prepared it. I just need to attach it to my activity. There's a method called setContentView. You call that, you pass in the text view, and then now they're attached. At that point, you have a hello world app running. You should be able to plug in your phone, enable developer mode, and then just hit play, and you should see your app running, and it should say hello world. Or your emulator if you're using that. Now the issue with this is many apps will have really complicated hierarchies for views. So the Gmail app, as I said, there's the list, there's buttons at the top, there's the menu that comes in from the side. Now it's from the side, it could be changed by the time you're viewing this. And then even in your list, you have hundreds of views there. You have, keep in mind it's a hierarchy, so it all starts with one view group, and then you have your action bar at the top, and then you have your list. And within your list, you have many, many items. Within every single item, you have an image. And beside it is also a text view, another text view beside it. With the one of them is the headline, one of them is the content body, and so on and so forth. There's lots of views. Imagine doing that in code. You would have to create every single view, and then you would have to also add the data into it, and then you'd have to build up the hierarchy manually. You would have to take every single view and add it to its parent, and then find the view at the very top and attach that to your content. It's impractical to actually build an entire activity like that. It gets annoying. I know a lot of people do that on iOS. It's a lot less common on Android. So the way you actually do it is, as I said, you do it interactively. You use XMLs. So now what we're going to do is actually define the layout hierarchy or the view hierarchy resources in XML. You do that by creating a new file, as I said, again, Command M or Control N if you're using Windows. Type in XML and it should show you an option for Android XML file, Android XML layout file. Click that, give it a name. The convention is activity_main if it's the main activity. And then you want to override onCreate, and you don't want to, you no longer want to create the view there. You just want to attach it to the resource. So whenever you define something in XML, what Android Tools does for you is it creates a resource ID for that. And that number, that resource ID, is what you use in your activity class to tell the Android system, hey, that resource XML file I defined, that is what defines your view hierarchy. And that also makes it really useful in terms of being able to reuse things. So let's say you wanted more than one activity with the same layout hierarchy. You can just reuse the resource ID without having to copy any code. So now we've created the XML file, we've attached it. If you run things, you should see an empty screen. Now what we want to do is go into our XML file and actually create a text view there and set the text on it. We will do that in code. You define a width, a height, a text, and then everything should work fine. And that's basically it for lecture 1. All the subsequent lectures will have significantly more content in them, but this is the basic idea. This is the very beginning. I wanted to just walk you guys through Hello World and all the important components of Android. I threw a lot of information at you guys. What's really important is just knowing what an activity is, how it works, the lifecycle methods. The Android manifest, that's extremely important. That's actually created for you automatically when you create an Android project. You just have to modify it and fill it in with extra information. You need to remember how views work. The fact that there are view groups and views. Views are what you usually see, but view groups are also views. They help interactions between views. You can create them in XML, you can create them in programmatically, you should remember that. And then just how to do hello world in XML and how to do hello world in code. That's all for this lecture. Thank you guys, and we'll see you guys next week.